So, welcome to lecture series on advanced linear algebra. We have already understood the relation between the set of linear transformations which are defined over finite dimensional spaces with the set of matrices please. I mean to say the matrix representation of the linear transformations. In that context, let me also continue that one that let me take an example further. Let T be a linear transformation from F3 to say F2 defined by x1, x2, x3 goes to say x1 plus x2 plus x3 and x2 plus x3. Suppose I have taken this ones. So, consider B equal to say alpha 1 equal to 1, 0, 0, alpha 2 is equal to 0, 1, 0 and alpha 3 is equal to 0. So, this is an order basis over 3 tuple space F3 and B prime if you consider say beta 1 equal to say 1, 0 and beta 2 is equal to 0, 1. We know how to obtain the matrix representation of T related to B and B prime. So, let me consider this is equal to say capital A. Now, the question is, suppose a matrix is given to me, how will define the corresponding linear transformation? Is it possible to do it? I mean, let me talk about this specific example case please. So, here we can find see what is the matrix representation of A? A will be definitely again 2 cross 3 matrix. So, it will be a 2 cross 3 matrix. So, A will be equal to something like this A1, A2, A3 like this. So, we know the T alpha 1s, the coordinate matrix of T alpha 1 with respect to B prime is the first column, that is A1. So, T of alpha 1 will be equal to what here, that is 1 and 0, implies that if I write C1 into your beta 1 plus C2 into beta 2, so certainly C1 equal to 1 and C2 equal to 0. So, 1 0 will be the first column and T alpha 2 again similarly B prime, this is A2. So, T of alpha 2 equal to here 1 and 1. So, this implies that C1, okay, this is equal to also I can add C1 comma C2, they are according to definition of beta 1 beta 2. So, okay, C1 and C2, C1 equal to 1, C2 is equal to 1 and similarly T alpha 3 we equal to basically 1 and 1. So, I will have again 1 1. So, I have got 2 cross 3 matrix A, fine. So, then can I express with the help of the A the linear transformation T for this case? Now, for this case to define T, I have to take T of here any say capital X which is equal to say x1, x2, x3 if you call it like this. This will be equal to, you have to write your x1, x2, x3 into A transpose. You can check it, this is equal to x1, x2 x3 into A transpose means they are 1 1 1, then 0 1 1. So, this is equal to x1 plus x2 plus x3 comma x2 plus x3 please. Okay. So, in this example what I found that if the T is a mapping from 3 tuple space to 2 tuple space, and if I represent capital A as the matrix representation of T related to B and B prime, when B and B prime is given to us please. So, in this case and the linear transformation T can be defined as x into A transpose please. Now, let me do the similar thing for this changing the space please. Now, if I consider example 2 say T is a map from instead of 3 tuple space I will say 3 cross 1, I mean set of all 3 cross 1 column matrix space to F2 cross 1, x1, x2, x3 transpose goes to say x1 plus x2 plus x3 comma x2 plus x3 transpose. Now, I am defining the transformation from F3 cross 1 to F2 cross 1 mapping that column vector goes to another column vector 2 cross 1 column vector place. Now, I will also consider B is equal to here similar, my alpha 1 is equal to I will take 1 0 0 transpose and alpha 2 is equal to 0 1 0 transpose and alpha 3 is equal to your 0 0 1 transpose, and B prime is equal to say beta 1 1 0 transpose and beta 2 is equal to 0 1 transpose. Now, again if I go the matrix representation of T here with respect to B and B prime, that is equal to what? See, again I have to see T of alpha 1, according to this already we have done, this is equal to 1 comma 0 transpose please, and so I have to write down this is equal to C1 into beta 1 plus C2 into beta 2. So, if I do it, then this is I am getting C1 equal to 1, C2 is equal to 0. Let the matrix representation of T with respect to B and B prime is equal to this is B matrix. So, it will be here again 2 cross 3 matrix. So, I will have 1 0 first column and T of alpha 2 will be here 1 1 1 transpose, and again I will have second column as 1 1 and T of alpha 3 equal to again 1 1. So, this will be equal to again this is 1 1. So, you see the matrix representation of, so let me give the name T star, then matrix representation of T star for this case is equal to same, this is the matrix equal to same what we have obtained in my previous example please, example 1. But here the linear transform T can be defined here T of x1, x2, x3, this is transpose. So, this will be mapped to the like your 1 1 1 0 1 1 x1, x2, x3 please. With the help of this matrix representation of the linear transformation, one can also go to the corresponding linear transformation. One can define linear transformation also, please. Okay. Now we are curious to know one things that we have seen for any linear transformation T from vector space V to W, where V and W are finite dimensional and then for any pair of order basis, this is B and B prime, or this is B is the basis for the V and B prime is order basis for W, we have a matrix representation of T, fine. Now, consider T is a linear operator on a finite dimensional vector space V of dimension n over field say capital F. Now, I have considered this one please. Let B equal to alpha 1, alpha 2, alpha n be an order basis for capital V. Since my V and W are same, so therefore, I will also have matrix representation of T related to the order basis B and B, because both are same. I will also have some matrix that will be, say, let us consider capital A, where A is a n cross n square matrix over capital F. For sake of simplicity, I will write down this as a simply matrix representation of T related to order basis B, that is equal to say capital A, please. I am writing like this, please. Now, consider B prime is equal to alpha 1 prime, alpha 2 prime and alpha n prime be another order basis. This is for B. Let the matrix representation of T related to order basis B prime is equal to say simply B matrix, please, which is also n cross n square matrix over F, please. Now, we are curious to know whether any relation between A and B exists or not. Does there exist a relation between A and B? That is the question, please. So, answer is yes. Now, how to obtain that relations? What is that relations? So, let us analyze that one, please. We have for any alpha belongs to B, coordinate matrix of alpha with respect to B is equal to basically coordinate matrix of alpha with respect to some non-singular matrix P times coordinate matrix of alpha with respect to B prime. If you recall these relations, that coordinate matrix of alpha with respect to order basis B equal to some non-singular matrix invertible matrix P times coordinate matrix of alpha with respect to B prime, please. And that is again because we know, since we know every alpha j prime can be written as linear combinations of alpha I equal to 1 to n, and if I say that coordinate matrix of alpha j with respect to order basis b is equal to, say, equal to capital X, and coordinate matrix of alpha with respect to b prime is equal to, say, x prime, then we know alpha equal to sigma x j alpha j like that. So, j equal to 1 to n, and then this will be equal to sigma x j prime and p I j alpha I equal to 1 to n, j equal to 1 to n. Exchanging the order of the summation, I will have, this is nothing, p x j when p I j and x j prime j equal to 1 to n and times your alpha I equal to 1 to n. So, this implies that capital X is equal to p into x prime. So, using this we can check that for any alpha belongs to V, coordinate matrix of alpha with respect to order basis B equal to the invertible matrix P times coordinate matrix, this one please, this one. So, coordinate matrix of T alpha with respect to B will be equal to coordinate matrix of T, I mean matrix representation of T related to order basis B times coordinate matrix of alpha with respect to order basis B. So, this is also we know it. We have proved just now please. Then coordinate matrix of again T alpha with respect to B prime will be again B prime into B prime please. So, this implies we have coordinate matrix of T alpha with respect to B equal to coordinate matrix of T, this one, and this is equal to P times coordinate matrix of alpha B prime please, because coordinate matrix of alpha with respect to B equal to P times coordinate matrix of alpha B prime please. This implies from 3 we have coordinate matrix of this one B prime equal to B into alpha B prime, but this is equal to P inverse coordinate matrix of T alpha with respect, this is equal to, again right hand side is equal to B prime and alpha B prime So, this implies that P inverse coordinate matrix of T, this one alpha B equal to B prime and P inverse into coordinate matrix of this one. So, this implies P inverse coordinate matrix of T with respect to B minus coordinate matrix of T B prime into P inverse into coordinate matrix of alpha B equal to 0. So, this is true for all alpha. So, this implies P inverse T B equal to coordinate matrix of T B prime into P inverse. So, multiplying P both the sides will have P inverse coordinate matrix of P, this one equal to B prime place. So, this implies P inverse matrix representation of T related to order basis B into P equal to matrix representation of T related to B prime place. So, this is the relation please. So, this implies if it is given to us, if the matrix representation of the operator T related to the order basis B equal to say capital A, then P inverse AP equal to this B matrix. I can conclude like this in terms of theorems like this. Let V be a finite dimensional vector space of dimension n over the field say capital F. Let B equal to alpha 1, alpha 2, alpha n and B prime equal to alpha 1 prime, alpha 2 prime, alpha n prime be two order bases of capital B. Let T be a linear operator on B. Then matrix representation of T related to order basis B prime equal to P inverse matrix representation of T related to order basis B into P, where P is an n cross n invertible matrix over capital F, and if P is equal to say P1, P2, Pn, this n column, the jth column Pj denote coordinate matrix of alpha j prime with respect to order basis B. In fact, if P is any n cross n invertible matrix over capital F and T is a linear operator on V of dimension n, and let B equal to alpha 1, alpha 2, alpha n be an order basis of V, then there exists another order basis B prime consisting of this alpha 1 prime, alpha 2 prime, alpha n prime, such that coordinate matrix of alpha j prime with respect to order basis B is equal to jth column of P please. In fact, there is this order basis B prime such that this is like this, and matrix representation of T with respect to order basis B equal to P times matrix representation of T with respect to B prime multiplied to P inverse please. Okay, so we have seen the existence of that type of relation, already we have proved it please. Now, if one give an invertible matrix P and suppose one order basis say B of V is given to us, then we can immediately find another order basis B prime consisting of alpha 1 prime, alpha 2 prime, alpha n prime, where coordinate matrix of alpha j prime is basically the jth column of the matrix P please, and then this relation also holds good please. Okay. So, construction of the alpha 1 prime, alpha 2 prime is basically already we have seen it. If a invertible matrix is given to us, then alpha j prime can be constructed like this. Whether this alpha 1 prime, alpha 2 prime and alpha n prime will be linearly independent or not, that is a question please. We can immediately check this will be also linearly independent. I want to give you as a home assignment to cross check that the alpha 1 prime, alpha 2 prime, alpha n prime constructed by this method, I mean where alpha j prime is equal to sigma p I j alpha j when P matrix is given to us. Okay, so, we have to prove that alpha 1 prime, alpha 2 prime and alpha n prime is order basis for the vector space V please, and with respect to that basis this type of relations also holds good, that we have to prove it please. Okay. So, now let me consider some examples and see it please. Okay. So, let me consider T be a linear operator from V which is equal to say F 3 cross 1, I mean set of all 3 cross 1 column vector please over the field F. Now, this is linear operator on V please, say T of any alpha equal to something A alpha, where A is 1 2 minus 1 1 0 1 2 1 0 something like this. Suppose A is this one please. So, here alpha means basically 3 cross 1 column vector. So, I can say let alpha is equal to x 1 x 2 x 3 transpose please. So, T of alpha is equal to 1 2 minus 1 and 1 0 1 2 1 0. So, suppose this one. Consider 2 order basis B equal to our standard order basis for F 3 cross 1 which is similar to F 3, only instead of row it will be column, just taking the transpose. So, my first one is a, so let me consider E 1 equal to 1 0 0 transpose and E 2 is equal to 0 1 0 transpose and E 3 is equal to 0 0 1 transpose. This is the standard basis on F 3 cross 1 please. And another one say B prime is equal to say alpha 1 prime, which is equal to 1 1 1 transpose, and alpha 2 prime is equal to say 1 1 0 transpose, alpha 3 prime is equal to say 1 0 0 transpose. So, we can immediately check that B and B prime are the order basis for the space F 3 cross 1. So, that we can check it, it is not a difficult task space. Now, let us see the matrix representation of T relative to order basis B and matrix representation of T related to order basis B prime, please. Okay. It is given to us T of x1, x2, x3 transpose, this is equal to 1 2 minus 1 1 0 1 2 1 0. So, this is a given matrix A into x 1, x 2, x 3. Okay. So, this means that let matrix representation of T with respect to order basis B equal to say, I can give the name as capital G, some name. Then what is capital G? So, certainly the G will be 3 cross 3 matrix, please. Now, T of 1 0 0 transpose, if I consider this one, that is equal to how much? This is equal to 1 2 minus 1 1 0 1 2 1 0. Okay. So, this into 1 0 0, this is equal to, I will have simply 1 1 2. I mean to say I am getting the first column of this given matrix A itself, please. So, this I have to express as a linear combination of the basis element of E1, E2, E3. So, this is equal to C1 E1 plus C2 E2 plus C3 E3. If I consider, then we will see that C1 equal to 1, C2 is equal to 1, C3 is equal to 2. So, G, this is a matrix 3 by 3 matrix I am getting here, first column will be 1 1 2. Similarly, 0 1 0 transpose, this will give me second column, you can check it. This will be again this into your 0 1 0, it will give me 2 0 1. So, I will have second column will be 2 0 1, and similarly third column will be minus 1 1 and 0. So, the matrix representation of T with respect to order basis B equal to that matrix. So, G equal to the given matrix A itself. Now, what can you say about the matrix representation of T with respect to B prime? Okay. So, for that again I have to see image of T of 1 1 1 transpose, that is equal to 1 2 minus 1 1 0 1 2 1 0. So, this when you multiply to this 1 1 1, okay. So, I am getting is equal to, so is equal to 2, then this is again 2 and this is equal to 3. So, I am getting this one. Now, this is equal to, I have to express into the basis element, corresponding basis element. So, this is equal to C1 into 1 1 1 plus C2 into 1 1 0 plus C 3 into 1 0 0. So, this is equal to, so if you simplify, that is C 1 plus C 2 plus C 3. The first row will be C 1 plus C 2 plus C 3, second will be C 1 plus C 2, and third one will be simply C 1. So, this will be the column, please. If I write say H equal to matrix representation of T with respect to B prime, then the first column will be the coefficient C 1 C 2 transpose. I am getting here C 1 equal to 3. So, I will write down 3, and C 2 is equal to C 1 plus C 2 equal to 2, already C 1 equal to 3. So, C 2 will be 2 minus 3 is equal to minus 1, and the next is C 1 plus C 2 plus C 3 is equal to 2, already C 1 plus C 2 is equal to 2. So, C 3 is equal to 0. So, this is first column is this one. Now, again this matrix when operating on second one, please, that is 1 1 0, this will give me 3 1 and 3. So, this is again equal to same C 1 plus C 2 plus C 3. So, this implies my C 1 is equal to 3. So, again I am getting 3, okay, and C 1 plus C 2, that is equal to 1. So, C 2 is equal to 1 minus C 1, 1 minus 3 is equal to minus 2, and next is C 3 is equal to, so it will be 2. Now, the next is again for the 1 0 0, when 1 0 0 there, I will have basically 1 1 2, last one is 1 1 2, 1 1 2, this is equal to this C 1 plus C 2 plus C 3, C 1 plus C 2, and this is C 1. So, this implies C 1 equal to 2, I will keep it right 2, and C 2 is equal to 1 minus 2 is equal to minus 1, and C 3 is equal to again 0. So, we will have this one. So, I will have the matrix representation of T relative to order basis B prime equal to capital H equal like this matrix, please. Okay. Now, our aim is to find a non-singular matrix P such that H equal to P inverse G into P. We want to find an invertible 3 cross 3 matrix P such that H equal to P inverse G into P, that we have to find it, please. Here Pj is nothing alpha j prime, coordinate matrix of alpha j prime with respect to order basis B. So, I hope you will be able to calculate this and cross check, please. So, please complete this work, and if you have any difficulties you can raise your questions. I hope this is definitely will help to understand our next lecture, please. Thank you.